Welcome to this video, which will introduce a new feature going with AOS-CX 10.11 and which is called Dynamic BGP peering. During this session, we will cover the following sections, so the overview of the feature and the use cases. We will also see the details and the caveats of Dynamic BGP peering, configuration and best practices. We will also have a troubleshooting section, and we will conclude this session with a demo. So let's start with the overview. So first, let's dive into some acronyms and definitions. So for this new feature, the key concept here is passive device. So passive device means this is a device which will never initiate a BGP connection by itself, depending on the scope on which we have configured it as a passive device. So it will always wait for its peers to initiate the BGP connection. So what is dynamic BGP peering? So before 10.11, we had to declare each BGP neighbor twice using its IP address. So the first time in the global BGP configuration to create it, and the second time in the associated address family to activate it, because even if those neighbors were part of a static peer group, we cannot activate this latest by itself. And everything had to be done manually because we are talking about static BGP neighbors. So now with the new dynamic BGP peering feature, we can now create a peer group in the global BGP configuration context, and we only have to associate an IP range to it. So it means that using this new capability, we do not need anymore to create all the peers individually, neither to activate them. So once it has been done, the device will start to listen to incoming connection and accept them if they match the different criteria that we may have defined in the configuration of the peer group. So if we look now at how BGP works before 10.11, so just to illustrate what we have just said, we are going to take the example that you can see here on the left side of the slide. So with this network, to implement the BGP infrastructure with peer groups, we need to create the peer groups, obviously, to associate some options to them, like the remote AS number, to create each remote peer one by one, putting them in a peer group, and finally activate them one by one as well in an address family, as we cannot activate a peer group. So when you only have 2 or 3 neighbors, that could be fine. But now that we are moving forward with larger BGP networks in the campus or in the data center, we could need to get dozens or hundreds of neighbors to configure. So this can be very time consuming in terms of manual configuration and also a source of errors. So now with the new dynamic BGP peering feature, if we take the exact same network, we just need to create a peer group and associate an IP range to it. So it will automatically start to listen to incoming connection from this IP range as a passive device. If a connection arrives, it will accept it based on the criteria that we have defined, configure this new neighbor as a member of this peer group, and put it in the corresponding address family. This new neighbor will automatically inherit all the configuration related to this peer group. So as you can see on the snippet here, the configuration is highly reduced, allowing us to save a lot of time of configuration to be more dynamic and so less prone to error. But there is also an important thing to note. This is the fact that dynamic BGP peering can work with both iBGP and eBGP peers on the same device. This is not mutually exclusive. And also that it supports all the address families that we have today in AOS-CX. So it includes IPv4 unicast, IPv6 unicast, L2VPN, EVPN, and also VPN v4. So now, let's see how it works. So on the setup displayed on the top right of the screen, we have a passive device, which is called spine1, and 2 leafs, so leaf 1 and leaf 2. Spine1 has been configured with a peer group, which is called leafs, and is listening on the given subnet, so 10.0.1.0/24. On the leaf side, both devices have been configured with spine1 as a remote peer, and it has been activated in the address family IPv4 unicast. So one important thing to remember is the fact that dynamic BGP peering follows the exact same process than with a legacy static neighbor or legacy static peer group in terms of exchanges. There are only two differences. You don't need to configure the listener as passive for a given peer group because it is automatically done, in the backend. A connection is always initialized by a remote peer, never by the listener. So if we come back to our example, leaf1 and leaf2 initiate their BGP connection with spine1 by sending TCP packets. And once the initialization is done and successful, both sides start to exchange BGP open packet. The listener will use information in this open packet, so the AS number, the BGP identifier, and the BGP capabilities, to accept or reject the connection and put the neighbor into the corresponding address family. So you can see here an example with the open packets coming from leaf1 and leaf2, and the result using a show BGP all summary on leaf1, on spine1, We can see the AS number, the BGP identifier, which will be used to identify the remote IP address, and the address family capabilities used by the remote peers. So on the spine side, you can see that now the two leaves have their session established and have been put in the correct address family. So now let's move on with the use case. So the first and maybe most important use case is the one that we have already presented, which is the configuration and management scalability. On a BGP perspective, the solution to improve the configuration by itself, as well as its scalability, is to use IP ranges instead of individual IP addresses for each neighbor. It will reduce the time to configure, the complexity of this latest, but also to save CPU in memory because we don't have to browse each time we have a new incoming connection to browse the BGP neighbor tables to check if the incoming connection is something which has been configured and which could be accepted by the device. You can see in this example how we can easily reduce the configuration for only 5 static neighbors. So I'll let you imagine the impact if we have dozens or hundreds of neighbors to accept because we are talking about a root refactor or this kind of thing. The second use case is related to Azure Stack. So Azure Stack uses today a mechanism which is called SLB MUX, and which allow VMs to peer directly with the top of racks using BGP. But it also requires to be able to specify a subnet as a BGP peer on the top of rack because VMs might dynamically change their IP addresses. So the top of rack must automatically and dynamically adapt its peering to handle this use case. So until today, only Comware in the Aruba portfolio was supported with Azure Stack using the configuration snippet that you can see on your slide. Okay, so you can see in this configuration that we are peering with a subnet. But now, with dynamic BGP peering being supported on CX as well, we can use it using the configuration that you can see here, because we can now declare a subnet that we want to listen to accept incoming connection. The third use case is related to the day-to-day operation, as it can simplify installation and migration. So for the installation part, we already discussed about it, but in addition to the fact that we don't need to configure each peer individually, which is the first benefit, it also allows to not have to pre-provision each peers, meaning that if we don't know the IP address, which will be used by the remote peers, and as an example, because we are using an automation workflow, including an IPAM, we just have to listen to incoming connection for a given subnet. For the migration part, we can find two use cases. So the first one is when you need to migrate the peer from one address family to another. So using dynamic BGP peering, it means that you will not have anything to do on the listener side, as it will automatically put a neighbor into the correct address family based on the BGP capabilities found in the open packet and remove it from the previous address family. The second one is when you change the interface on a remote peer used as its update source. In this case, you only need to create a new peer group listening to the new IP range. So when the configuration is changed on the peer side, on the active side, the listener will automatically update its peering. So in this slide, we will just see two examples of the migration use cases. So the first example is about IP migration. So as you remember, we want to update the interface used by the remote peer, so the active peer, as update source. So we just need to create a new peer group listening to the new IP range. On the other side, we only have, on the active side, we only have to change the update source configuration, as you can see here. So we update the update source using, in this example, the loopback 0. And the listener will automatically adapt its peering, as you can see here. The second example is about address family migration. So we don't have anything to do on the listener side. We just need to make the change on the leaf side, so on the active side, by activating the listener on the new address family. And the listener will automatically adapt its peering, as you can see here, based on the information found in the open packet. Now the details and caveats. So just to summarize how dynamic BGP peering works and what is the decision tree. So first, obviously, a peer group must be created because this is a base element of this feature and it has to be enabled. Secondly, we need to configure an IP range for this peer group. Otherwise, nothing will happen because we don't have any default configuration. Once an incoming connection arrives, the remote address must match the IP range that we have defined. But we can also use two optional items, the AS number which are allowed, and also the maximum number of allowed clients for a given peer group. If an incoming connection failed to match those criteria, it will be rejected by the system. As we already said, peers listening on an IP range are always passive. So they will never initiate BGP connection by themselves because it doesn't know the peer's IP addresses until they initiate a session. But also, let's imagine that we have several peer groups with overlapping IP ranges. If an incoming connection matches several of these peer groups, the peer group with the longest prefix will be used. Another detail is the fact that you can continue to use both static peers and static peer groups on devices where dynamic peer groups are configured. This is not mutually exclusive. This is not because you are using dynamic peer group on a device that you cannot create static peers and static peer group. You can continue to use them as well for any other need. Another important thing is the fact that as of today, we cannot use the 0.0.0.0/0 as an IP range to get a kind of default group. This is not supported by the system, as you can see on this example. It will tell you that the IP range that you are trying to configure is invalid. An important thing to take care of is the TTL used in the open packets. So it's really important to note that by default, this TTL is set to 1. So I mean, when an open packet is sent by the listener, by default, the TTL in this open packet will be set to 1. But it can be modified on a per group basis. So how can we modify it? The TTL will be automatically adapted to the AS range option that you can specify when you configure a dynamic peer group. If the new peer group is for iBGP peers, meaning the AS number that you declare in the AS range is the same than the local one, AOS-CX will set the TTL to 255. In the other hand, if the new peer group is for eBGP peers, meaning that the AS number you declare is not the same than the local one, AOS-CX will set the TTL to 1. But in terms of configuration and behaviors, what does it mean exactly? So as we already said, if you do not configure an AS range, the only allowed AS number will be the local one. And the TTL in the open packet sent by the listener will be set to 1. So in this case, only the single hop IBGP peers will be able to establish a BGP connection, and so will be accepted by the listener. So as you can see on this example, if the leaf, here you can see the example, so we have a spine, we have a leaf, and we have an intermediate node, and we can see that the leaf is multi-hop away from the spine. So it is not a single hop BGP peer. So if the leaf is more than 1 hop away from the listener, the connection on the leaf will remain in an open state on its side, so on the leaf side, because the open packet from the listener will not be able to reach out to it, because the TTL is set to 1. In this case, if we want to accept multi-hop BGP peers, the solution is to declare the local OS in the AS range. In this case, it will allow to set the TTL to 255 in the open packet sent by the listener. The other thing to mention regarding configuration and behaviors is when you are using both IBGP and eBGP peers in the same dynamic peer group. In this case, as the TTL is set for the whole group, it will be set to 255 for the IBGP peers, but also for the eBGP peers. That's why if you try to configure the eBGP multi-hop option, the command will be rejected by the system as the TTL is already set to 255. You can see here an example. We have both the local AS and a remote AS. And so if you try doing that, the TTL is automatically set to 255 even for the eBGP open packet. And so if you try to configure the eBGP multi-hop option, it will say that this is an invalid command because we are listening to an AS range, and this AS range includes the local AS. Now, if you deactivate a dynamic peer group by doing a shutdown or by removing it from the configuration, the matching BGP peers will automatically be dropped from the system. The only peers which will remain with an established session are the ones which are statically configured, obviously, but also the dynamic peers with remote address matching a peer group with a longer prefix or from another dynamic peer group. Oh, sorry. So if we look at this example, we have a set of static peers, an initial peer group, and another peer group using a longer prefix. And we have some peering which are established, so one for the static peer, one for the initial peer group, and one for this peer group. If we shut down the initial peer group, or if we remove it from the configuration, only the peer which match this initial peer group, has been dropped. So you can see here that all the other peerings are remaining into the system as established. So the only peering which has been dropped is the one which is matching the initial peer group. Another detail is the fact that a dynamic peer group is automatically put in the good address family and is activated based on the BGP capabilities found in the open packet. In this example, that's why if we look deeper to the details of this neighbor, the address family L2VPN VPN received in the open packet. So we have automatically set the received capability as yes. And so that's why we are putting this neighbor into the address family L2VPN EVPN. Some other details. So first, you cannot get more than one subnet per dynamic peer group, including IPv4 and IPv6. Secondly, on the other side, you cannot use a given subnet for more than one peer group. And finally, if you clear BGP sessions on the listener side, all current sessions will be dropped. But as the listener is passive, you need to wait for the neighbors to reinitiate their session. So the active side will detect the socket error and retry the connection immediately. So it can take few seconds to get a newly established session. Last point of detail, let's say that you want to move an IP address or a set of devices to a new peer group. while they have already established their session, it won't automatically reset those latest. A clear BGP session made locally or on the remote peer, so on the active side, will force them to migrate, as you can see on this example. So we have made the change here, but the peer remains in the peer group, which is called leaf. So we have to make a clear BGP, so locally on the listener or on the active side, so the remote peer, and automatically it will be migrated to the peer group border. So now let's look at the caveats as of 10.11. So the first point to note is that you cannot shut down an individual dynamic peer. So as we don't have any activate command for a dynamic peer, we cannot negate it to close the session. But also the shutdown command cannot be used against a dynamic peer. So obviously, as we are using dynamic peering, the IP address are unknown by the system until they establish a session. So we cannot shut it. We cannot shut a peer before it has established a session. On the other side, if you try to shut down the peering using the IP address of a dynamic peer, it will be refused by the system. So the only way today to close a session without having to remove the dynamic peer group is to shut down this latest. But keep in mind that doing so, it will close all the sessions with the peers matching this peer group. The second caveat is when you are using an AS range. Instead of a list of individual AS numbers separated by commas, you cannot remove an individual AS number from this range afterwards. So the only way to remove it is to remove the whole range and recreate it. So you can see here that we have specified in the AS range option a range by itself, so a kind of list. So we didn't specify each AS separated by commas. But if you try afterwards to remove one AS from this list, it will be refused by the system. So the workaround as of today, if you think that some of the AS number could be useless afterwards, is to use a list of individual AS numbers separated by commas. The third caveat is related to day-to-day operation. So if you look at the details of a peer group, which is configured as dynamic, so listening to an IP range, you won't find this kind of details and information using show BGP, the show BGP all peer group, or any show BGP command related to a peer group. Okay, so you won't have any information related to the fact that this is a dynamic peer group. So if you need to check this kind of configuration, as of today, the only way to do that is to look at the configuration in the running configuration. Finally, you won't find any information if a remote peer has been rejected and the reason of this reject, even in the events. So if you need to troubleshoot incoming connection, you need to enable BGP debug and look at the related messages using terminal monitor or going to the shell. About support and scalability metrics now. So as of 10.11, dynamic BGP pairing feature is supported on all platforms supporting BGP. So starting with 6300 to 10K, as well as on the simulator, so the OVA. So you'll find here the scale of the following items. So the number of dynamic peer groups that you can create, the maximum limit of clients per dynamic peer group if you don't specify a limit. And finally, the maximum number of AS numbers per dynamic peer group. So using the two supported format, comma separated list, but also if you declare it as an AS range. So you remember the format that we can specify a start AS number and an end AS number with a dash. So now let's discuss about the configuration of this new feature, so dynamic BGP pairing. So first, let's look at the different configuration options. So as we already mentioned, the first thing to do is to create a peer group, so which is a base element of this new feature. Once it has been done, a new command has been introduced in 10.11, and which is named listen. So using it, you can then configure, as you can see here, an IP range. So those two items, the peer group and the IP range, are the items which are mandatory to get dynamic BGP peering up and running. But you can also specify two options. First, the AS range, which will replace the remote AS argument that we must use with static peering. If we don't specify it, the listener will accept peering only from the local AS and only from peers which are one hop away from the listener. So this option needs to be used to accept incoming connection from remote AS using BGP, but also for iBGP peers, which are more than one hop away. As you can see, we can, so as you can see, we can use a BOS notation, so the AS plane, but also the dotted format. The second option is the limit, which will determine the maximum number of clients that we may want to allow for this peer group. If we don't specify it, we will accept peering as long as we have IP addresses available for the configured subnet. For IPv6, there is no difference in terms of configuration, and you can use the exact same process with the same options. You can see here a basic configuration for both IPv4 and for IPv6 with snippets from the listener side, and also for information as well. We have put in the right side of the slide the configuration from the client side, and you can see that there is no difference in comparison to the classic BGP configuration, because on the active side, so on the client side, we are still using static BGP peers. As we already said, dynamic BGP peering is supported for all the address families that we support today on AOS-CX. So it includes IPv4 unicast, IPv6 unicast, L2VPN, EVPN, and VPN v4. So another point of configuration is the fact that for a given address family, if you need to use a specific community, you need to specify it in the address family context, just like with static neighbors. So you can see here that we can declare, we can use the neighbor, so the peer group that we have created, and we can configure the community that we want to use. But for the worst thing here is to note that you can obviously use all the BGP configuration items, as it remains identical to a static peer or a static peer group. So it includes the authentication, it includes the update source interface, it includes the route maps, it includes route reflector client declaration, and even if you want to keep using the remote AS argument, you can use it with a dynamic peer group instead of the AS range option. So also, listener can be used for both iBGP and eBGP peering because this is not mutually exclusive. So as you can see on this example, we can create a dynamic peer group here for iBGP peers, and we can also have another peer group for eBGP peers. And so, following that, we will have both kind of BGP peers, so iBGP and eBGP peers, which will be accepted by the system, and so which will have their incoming connection accepted and session established. So following what we have already said, this method is the preferred one to be able to use different TTL regarding the fact that we are using iBGP on one side with a TTL which could be 255 and eBGP with a standard native TTL which could be set to 1, except if we declare an eBGP multi-hop option. But if needed, we can also support iBGP and eBGP peering within the same dynamic peer group. As you can see here, so we have the local AS here and the remote AS here in the same peer group, dynamic peer group, and both kind of peers will have their session established. eBGP multi-hop is also supported, as we already mentioned, and you can apply it with a number of hops to a dynamic peer group. Route maps are also supported in and out, just like with static neighbors. And there is an important point to note also, and this is the fact that we support multiple peer groups with overlapping subnets. So in this case, a peer will match the peer group listening to the longest IP prefix. So as you can see on this example on the left, we have two peer groups, one initial, listening to the /24, and we have another peer group, another dynamic peer group, just listening to a /32. So it's listening to a given peer, a specific peer. And so using this configuration, you can see here that the incoming connection from this device will be accepted, and the device, this peer, will be put into this peer group, so the VTEP specific, because we have accepted it using the fact that this peer group has the longest IP prefix. But the thing which is important also to note is that there is no inheritance between peer groups with overlapping subnet. It means that they are considered by the system as totally independent, and so you need to configure them as such. Another point to note is that even if it's supported, this is not necessarily recommended. The fact that you use overlapping system could complexify the configuration in terms of readability and operation. Using dynamic peer groups can also be used in the context of confederation. The only point to take care of is obviously to not use all devices ending eBGP connection as listener only. Otherwise, the eBGP pairing between the sub-ICs will never come up. So here is an extract of the configuration used between the two sub-ICs that we had on the previous example. So you can see that on spine 1, we have statically configured the eBGP pairing with another sub-IS to initiate the configuration. So we are listening to the local iBGP pairs, but we are trying to initiate the connection, the BGP connection, to another sub-IS. Last thing is obviously that we support REST API, so we can get all the information using REST API request. So for a given peer group, we can get the IP range, the optional IS range that we allow, the optional maximum client limit, and also the number of dynamic peers with an already established session. If you need to get information about the dynamic peers by themselves, you just need to use a filter with origin set to dynamic neighbor. So using this filter, you will be able to retrieve all the dynamic BGP peers. Obviously, you can also use POST to create those dynamic peer groups into your automation workflows. Before moving to the demo, what are the best practices when you are using dynamic BGP peering? So the first one is to set authentication. As we are listening to a subnet, by default, we can accept all incoming connections for that subnet. So to control unexpected devices, it is recommended to use authentication. The second best practice is to enable the IP range only once you have configured everything, including the arguments and the options. So remember that once you configure the IP range, it will automatically start to accept incoming connection. So to avoid any instability afterwards, first create your peer group, configure your options, and then at the end, enable the IP range for that peer group. The third best practice is to use update source interfaces which are contiguous and logical. So as we have on this example, avoid to use IPs like 1.1.1.1 or 3.3.3.3. Otherwise, it could be difficult to define the IP range to listen to because we do not support 0.0.0.0/0. So in this case, if you are using this kind of IP addresses for your loopback as an example, it will be difficult to specify an IP range to listen to. Dynamic BGP pairing is obviously also supported with VSX async. So it is always the best practice to use VSX async when we can in order to avoid any configuration errors or drift between the VSX peers. To avoid any issue regarding TTL between iBGP and eBGP peers, it is also an important point to use different peer groups for iBGP and eBGP peers. Okay, so this is just for operation. It will allow you to simplify your day-to-day operation and the readability of the configuration. So when you can, use one dynamic peer group for iBGP and one other dynamic peer group for eBGP peer, or several other dynamic peer group for your eBGP peer. Finally, regarding overlapping, as we already mentioned, it is supported but not recommended. So avoiding overlapping will allow you to get a simpler and more readable configuration and to avoid any side effects in case of a peer, in case you have a peer which is not matching to the correct peer group. Okay, so when you can, avoid to get dynamic peer group listening to overlapping subnet. Finally, it is always also recommended to configure an AS range, at least to declare your local AS for iBGP peer groups, for iBGP peers, sorry. So, as we mentioned, the AS range is optional. So it means that by default, if you don't specify an AS range, it will listen to your local AS. But remember that in this case, the TTL will be set to 1. So if we want to get a TTL set to 255 for your multi-ops iBGP peers, configure an AS range. So a best practice in this case is to always, even if it's optional, to always configure an AS range, even if it's only to get peerings from your local AS, so from iBGP peers. But also in the future, it will allow you to accept, if you really want to create a common peer group for both iBGP and eBGP peers, it will allow you to accept incoming connection from iBGP peers in case you really want to do that. What does it mean? It means that if you, as you can see here in this example, if you create only an AS range to accept a remote incoming connection from a remote AS, automatically all the incoming connection coming from your local AS will be rejected. Okay? This is not implicit. So if you want to accept connection from your local AS and remote AS within the same dynamic peer group, you have to configure both, so the local AS and the remote AS. Now let's move on with troubleshooting. So the first thing to note is how we can differentiate a dynamic peer versus a static peer. So with 10.11, each dynamic peer will be displayed with an asterisk in front of its IP address. And it will be the same for all BGP-related commands. As we mentioned, there are 3 reasons why a remote peer could be rejected by the system. The first one is the fact that the remote IP address is not in the IP range. Also, the AS number is not allowed, and we have already reached the maximum number of clients for this peer group. So for the first item, using the debug feature, if the remote peer is using an IP address which doesn't match any configured IP range, you'll get the following trace with a specific warning message that you can see here. And the BGP error subcode will be set to connection rejected. Now, in case a peer has been rejected because of its AS number, you will get the trace as displayed here in the slide. It has to be noted that bad AS number is the only error which won't have a specific warning message. So you can identify it using the BGP error subcode, which will be set to bad peer AS. And finally, if we have already reached the maximum number of clients, we will also have a specific warning message that you can see here in the trace, and the error subcode will be also set to connection rejected. Here you can find some commands which could be used to check for dynamic BGP peering directly into the OVS DB. And finally, one thing that which has to be noticed is the fact that using Wireshark, so if you take a packet capture to monitor or to troubleshoot your BGP sessions or your incoming connection at the different BGP exchanges between your peers. So using Wireshark to read this packet capture, it appears that your open packet could be seen as malformed. So it seems that there is an issue with Wireshark and its detector, which doesn't treat some information as it should. Because if you check the exact same packet capture with TCP dump, you won't have any issue. So now let's move on with the demo. So for this demo, we will use the following setup. So one core device, which will act as a listener, two leaves within the same AS, which will establish eBGP connections, and one remote device in a different AS, which will establish an eBGP connection. So let's move on with the demo. So you can see here that I have 5 windows which are already open. So the 2 windows on top of the screen are my connections to my core, so to spine 1, which is the listener device, and the 3 windows at the bottom of the window of the screen are my connections to leaf 1 and leaf 2, which are my iBGP peers, so which are the devices into my local AS, and the 8325, which is considered as my remote device, and so which is located in a remote AS. So first, we will take a look at the configuration on both sides. So let me zoom in a little bit. It will be easier. So first, let's look at the configuration. So you can see here, and we will have the exact same configuration on the other leaf. So you can see, so it has been disabled for the demo. So the configuration is already done. So on my leaves, which are my active devices, I have configured my listener as a static peer, and it has been activated into the IPv4 unicast address family. And this is the same thing on the other leaf. For the remote device, I will have the same kind of thing, except the fact that here the local AS, so 65002, is not the same than the remote AS. So which means that we will try to establish an eBGP connection. So now if we go to the listener, you can see here that I have created 2 peer groups. So the first one is listening on this subnet, so 10.0.1.0/24, which is the one used by my iBGP peers. And I have declared an AS range, which includes my local AS, so 65001. I have also created another dynamic peer group, which is, in this case, listening to another subnet, so 10.0.2.0/24, and which will accept incoming connection coming from this AS number, so 65002, which is the AS number of my remote device. So now, if I go back on the demo, I will show summary. Okay, so you can see that I don't have any established connection. So we will do a repeat just to see the changes in lives. So we just have to go into router BGP 51. I will do the same here. Config BGP 50. Sorry. Okay, so I'm going to enable here, And you can see that my first IBGP peers is already up and running, so with an established session. And I'm doing the same on the other IBGP. And now I have this. So now I have my two IBGP peers which have their connection established, and we can see that we are talking about dynamic peers because we have the little asterisk in front of the IP addresses. If I go back on the remote device, so let's do the same thing. I will just make a repeat as well. Repeat, config, router BGP, so this one, and if we enable it, this is. Okay, so now you can see that even my eBGP peer has its session which is established now. We can see it with the remote AS, which is 65002. So doing that, and without having to declare those three neighbors as static neighbors in the listener configuration, everything has been established. So I have my two connections from my IBGP peers and my connection from my eBGP peer. So now, if we come back on the presentation, so to finalize this session, so some resources. Obviously, the IP routing configuration guide for 10.11 will be updated with this new feature. Thanks a lot, and I hope that you have enjoyed this video.